All right, we're going to call this Parabolas Part 1 because what we're going to do in this video is explain the definition of a parabola, and we're going to look at some simple parabola equations, all right, in conic form. Now, the definition of a parabola is it's the set of all points that are the same distance from a given point and a given line. All right, so I'm just going to draw a random point and a line. I can put my line anywhere. I'll put it right there. And now I'm going to start eyeballing some points that appear to be the same distance from this point as they are from this line. Of course, the first obvious point would be this one right here. This point is the same distance from this line as it is from my given point. And I'm going to go ahead and name my given point F so that I don't start getting it confused with the other points I'm going to put on the picture. Now, let me find another point that appears to be the same distance from F as it is from the line. All right, so just eyeballing, it appears that this point might be the same distance from F as it is from this line. Remember, to measure the distance from a point to a line, you go perpendicular. So this distance here looks to me to be about the same as this distance here. All right, well, let's find another point. All right, well, this point is getting pretty far out there. It looks to be about the same distance from F as it is from this line. And I can find some points on this side as well. Here, for example, is a point that appears to be about the same distance from my given point and my given line. Here's maybe another point that seems to be about the same distance from F as it does from the line. When I connect all of these points, then I should have what looks like a parabola. And that is the definition of a parabola. Now, because the definition of a parabola hinges on this point in this line, these two things have specific names. This point I called F is the focus, and this line is called the directrix. So when we look at parabola equations in conic form, we are also going to be talking about the focus and the directrix, as well as the vertex of our parabola. And we've talked about the vertex before when we've discussed quadratic equations. All right, so let's look at a simple parabola equation. Now, this time we're going to look at parabolas, not just parabolas that go up and down, but we're going to look at parabolas that might go up or down or open to the right or open to the left. All right? Now, the general equation for the parabolas that go up and down, the general conic form, looks like this. Y minus k equals x minus h squared. And I'm going to put 4p in front of this y minus k. Now we can say 4p or 4c. The sideways parabolas have this general conic form. It's x minus h. Well, I'm going to have to scoot that down just a little bit. It's x minus h equals y minus k squared, and my 4p is going to go alongside this x minus h. So the conic form of a parabola equation looks like this if you're talking about a sideways parabola, or it looks like this if you're talking about a vertical parabola. Now, you can also have these angled all kinds of ways, and those involve other skills, and we're not going to get into that in this video. All right, so a little bit of glare right there. Make sure you can see that equal sign. Now, we are going to look at some simple conic form equations and discuss the importance of hk and this variable p in our equation. All right, so here's one. 10y equals x squared. Now, 10y equals x squared looks like this form right here. So this is going to be a parabola that either opens up or it opens down. All right? Well, in this equation, you can see that I'm not subtracting anything from y, and I'm not subtracting anything from x. That means that h is 0 and k is 0. So hk, which is my vertex, For this parabola, HK is 0, 0. All right, now, so I have HK, my vertex is 0, 0. Because this 10 is positive, we know that this opens up. So already I can sketch a general curve of my parabola. The vertex is at 0, 0, and it's going to open up. Now, the focus and the directrix help me determine how narrow or how wide my parabola is, and we're not going to really get into the specifics of that either, but we are going to identify the focus and the directrix, and we must know P to do that, because it just so happens that this distance that I kept referring to is P. P is the distance from the vertex to the focus. It's also the distance, you remember that's the same as the distance from the vertex to the directrix. So my directrix is going to be a line equation, and in this case it's going to be for a horizontal line, and it's going to be P units away from the vertex. Meanwhile, the focus is going to be a point, and it's going to be P units inside the parabola from the vertex. Since 10 is equal to 4P, then P is equal to 10 over 4 or 5 halves. So that means that I'm going to go up 2.5 to get my focus, which means that the focus in this case will be at 0 and then 2 1/2 or 5 halves. And then my directrix will be beneath my vertex by 5 halves units or 2.5 units, and it's a horizontal line, so it's y equals, so the directrix is y equals, and it's negative 5 halves. All right, let's do one more simple one. So one more simple equation. Let's say we have negative x equals y squared. Now, here again, I'm not subtracting anything from the x, okay? I'm not subtracting anything from the x. I'm not subtracting anything from the k. The y squared, from the y. The y is squared in this one, so we're talking about a sideways parabola. But because I'm not subtracting anything from x and y, my hk, or my vertex, is again the origin. That's what makes it such a simple parabola. All right, now this negative sign indicates that it opens to the left. The negative sign indicates it opens to the left, just like on an up and down one, the negative sign would indicate that we open down. Right, so my negative sign on 4P indicates that we open down, or sorry, to the left. So here's a brief sketch. Vertex is 0, 0. I open to the left, so my parabola is going to look like that. Let's find the focus and the directrix, because that's a little more information about my parabola. Well, negative 1, the negative number sitting in front of x, is 4p. It's equal to 4p, so p is equal to negative 1/4. That means that my focus is 1/4 of a unit inside my parabola. And since I'm starting at 0, 0, that means this point must be negative 1/4, 0. And then my directrix is going to be this time a vertical line on the outside of my parabola. And equations of vertical lines start with x. And so it's going to also be 1/4 of a unit away from the vertex. So it's going to be x equals positive 1/4. This is my directrix, and this is my focus, and this is my vertex. Those are the three main things to identify about your parabola.